with Professor Kaustubh Dhargalkar. Yes, that's right. Kaustubh is Associate Dean of Business Design at Business School We School in Mumbai, India. He also heads Inno Center for Innovation. Runner-up at the Wharton Innovation Tournament, he was granted the Entrepreneurship Educator and Mentor Award by the Government of India. The theme is a collaborate business model for reducing the real carbon footprint of electric vehicles.
Good afternoon, everybody. My topic is not really about traffic management, but more about creating a business model for reducing the real carbon footprint of electric vehicles. The major challenge that we face today is global warming, and the main effect is that global warming is a phenomenon that's been happening for a long time now. For the last 5,000 years, the temperatures have increased by 4 to 7 degrees, and they have happened just by themselves. And today, if we continue the way we are and contribute to the global warming, it's going to rise at 2 to 6 degrees in the next 100 years only. Now, that's a major, major problem. And greenhouse gases that we burn in our fuels are the main culprit, carbon dioxide being the main one. And if we continue the way we are, 23% of carbon dioxide emissions in the world today come from the transportation sector only. If mobility uses same fuels today, it's going to increase to 32% by 2030. Of all the carbon dioxide emissions coming from the transportation sector in India, 87% come from road transport alone. Hence, my focus here is going to be about reducing the real carbon footprint of the automobile sector. Now, over the last few years, the focus has been on reducing tailpipe emissions, and electric vehicles with zero tailpipe emissions seem to offer the greenest solutions. But where does this electricity really come from? This electricity comes from the normal grid that we access, and 83% of the electricity generated globally comes from non-renewable sources like coal and natural gas. So my question is the electric vehicle really a green option? At best, electric vehicles create a cleaner city, but it actually pollutes the countryside where these thermal energy plants are located. So unless electric vehicles draw electricity from renewable resources, we cannot say that an electric vehicle is really a green option. For electric vehicles to become really a green and a clean option, they should draw electricity from renewable sources such as solar, biomass, wind, thermal, geothermal, sorry, not thermal, wind, tidal, etc. Let us look at what electric vehicles are doing today. The current business model focuses on these factors: overcoming range anxiety. Range anxiety is the anxiety that a person faces that in the middle of a journey, the electric vehicle battery might get recharged. So rightly, electric vehicle manufacturers are focusing on increasing the capacity of battery packs. Secondly, they are trying to reduce recharging times. At present, a normal home connection charges an electric vehicles in about 6 to 8 hours. Even Tesla's quick charge technology takes 20 to 30 minutes to recharge the vehicle for maybe another 270 kilometers or so. But it is not as convenient as going to a gas station, waiting for 3 minutes, filling gas and moving off. So this is an inconvenience. Electric vehicle manufacturers are trying to compensate for that. The third point is that they are trying to improve the recharging infrastructure by providing more recharging points. And finally, they're trying to lower electric vehicle costs. All these attempts, no doubt, are in the right direction. But what about the carbon footprint of the electricity generation? For this, we need to create a different business model wherein clean energy generation becomes a part of the ecosystem of the electric vehicle manufacturer. How can this be made to happen? We got to create an ecosystem integrating all these renewable sources and to reduce the carbon footprint and higher popularity of electric vehicles. Here's what I propose. The electric vehicle manufacturers should have a holding company that invests in various satellite companies that generate clean energy from all these sources. Garbage collection, that is solid waste, smaller micro hydropower plants, tidal energy, geothermal energy, wind farms, and solar energy. The energy thus generated should be uploaded on a smart grid, and the holding company should be granted equivalent energy credits. The electric vehicle manufacturers could use these credits to recharge the batteries of electric vehicles that are sold by them at authorized service stations. The excess credits left can be used by them for trading with other electric vehicle manufacturing companies or other such carbon-heavy companies, industries. Thereby, we can create a thriving secondary market for green energy credits. Governments should offer lucrative tax benefits for income generated from trading of these credits. Now, this really needs a smart collaboration between various agencies and the government. So where are the electric vehicle manufacturers going to get additional revenue from? Listed here, they're going to get fees for recharging electric vehicles on a recurrent basis. They're going to get market price for the surplus energy generated, and they're going to get revenue from sale of energy credits as well. To understand the impact of this proposed models, I have taken the case study of Mumbai city in India and have explored two renewable energy resources such as biomass and solar. Let us look at biomass first. Mumbai has a population of 21 million people, each generating close to 650 grams of solid waste every day. That amounts to a whopping 13,650 tons of solid waste every day. Assuming only 40% of this is collected, and assuming that out of that collected, the efficiency of conversion is only 50%, we can generate 448 gigawatt hours of electrical power every year. And that will be enough to charge 67,237 electric vehicles per year, assuming that one vehicle runs for 20,000 kilometers per year. Actually, 20,000 kilometers per year is a pretty high run for a city dweller in India. It is more like 10 to 15,000 kilometers per year. So actually, the 67,000 could be 100,000 to 134,000 vehicles recharged per year. Now let us move to solar energy. Mumbai is blessed with about 8 hours of bright sunshine for 300 days a year. I have considered only 5 hours out of those because that's the angle of incidence of the solar on panels that can be effectively converted into electricity. Mumbai has 90 gas stations, approximately 90 gas stations, each covering an area of half an acre. And if these gas stations are covered by solar panels, that will generate energy enough to power to recharge 9,630 electric vehicles per year. Once again, considering the average of 20,000 kilometers running per year. It could be less, so the number of vehicles could be a lot more. Now, to demonstrate the business model in action, here's a short film. Let us hope it runs. Yeah. That's Mumbai city. Garbage collection, 13,650 tons of garbage, solid waste every single day. Going into a processing center, that's where it goes into. All that garbage, the solid waste processed, generates electricity, gets uploaded into a smart grid. That's an electric vehicle running across the city. At the end, it runs out of battery. That's the gas station covered with solar panels. Solar energy, electricity comes from that grid, from the smart grid, at the petrol pump, at the gas station. A electric vehicle with a discharged battery comes there, swaps it for a recharged battery, and goes off. That's how it will actually run in action. Now here we have considered only biomass and solar. The other renewable sources which can be considered will add further to the green quotient. Now the actual operations are going to be like this. Electric vehicles are expensive today. Electric vehicles are expensive today because 20 to 25% of its cost comes from the battery alone. So I'm proposing the sale of an electric vehicle without a battery and providing the battery as a subscription service. The electric vehicle comes to the gas station, swaps a battery for a recharged battery. This swappable battery technology was developed by Shai Agassi in 2007, so it can be used. Advanced telematics can be used to actually predict the stocking patterns of the batteries at various stations. That is, a battery can have sensors which tell the amount of recharge left in it, the kind of route that it takes, and accordingly, on that route, the batteries could be stocked. Now, that's how it will operate. What are the benefits to the consumer? Obviously, low upfront cost, a smoother and a seamless recharging experience. Obviously, higher adoption will result. What are the impacts on the ecosystem? Decrease in real carbon footprint since we are creating an end-to-end renewable energy channel. By creating energy credit market, there will be a healthy competition between auto manufacturers to produce as much green energy as possible, thus driving the cost of energy down further. Citizen engagement will be higher due to lower costs, which will fuel demand further for electric vehicles. This model uses the existing infrastructure and hence it's not going to be very, very investment heavy. The investments are not going to be heavy. Now, I have put forth this business model for an electric vehicle, but as you must have got it, in essence, it can be used and replicated for any electric appliance that uses electricity, such as an air conditioner, a microwave, a computer, a mobile phone, everything around us. Now, that's the power of collaborative models between government, electric appliance manufacturers, and various other agencies. Now, before I end, I would like to acknowledge the contributions of my colleagues, Mr. Akshay Gorkar, helping me with data collection, and Swapnil Chaudhary, who has helped me make the animated film. Thank you. And we are really looking for some good participation for these kinds of models across the world. Mumbai is just a case study. Thank you very much.
Thank you very much. Thank you very much, Professor Dhargalkar. I see the themes are very interesting, and so 10 minutes are very short. But has anybody a question to Professor Dhargalkar? There's one person behind. We have a microphone here.
Yes, just a question. All these models, do they take into consideration the effect on environment? Two clear points. Wind energy, collecting wind energy. Is there studies, what is the effect or the long-term effect on weather changes? Are there any research on this area? Because we are advancing new energies, but are there enough research to see, okay, wind energy is very good. What is the long-term weather change? This is one example. Another example is on batteries. What is the lifespan of a battery? What are we going to do with all these batteries, which are very toxic materials in batteries. So are these all models, all this renewable energy, are they taking into consideration the long-term effect on environment?
Yes.
Thank you.
Oh, yeah. Definitely an interesting question. The effect of, I have right now studied the effect of collection of solid waste and solar. Wind is in the pipeline. As you rightly said, wind farms do alter energy patterns. So that has been kept aside at the moment right now, yes. And the actual complete cradle to grave kind of life cycle for the electric batteries, yes, it is definitely not researched as much yet. But in the overall impact, my focus has been on creating an end-to-end green channel for right from energy generation to energy consumption. It is not just focused on the electric vehicle. My focus is more on where the electricity generated is coming from and creating green sources of energy to be put up in the grid. To counter today's 83% of energy that we consume comes from non-renewable sources. So the attempt has been to integrate renewable sources at the back end. Thank you.
Thank you very much. So we continue